Imagine you're about to bake cookies. Would you use dirty utensils or old, spoiled ingredients? Of course not. Data mining is just like baking. You need clean, fresh data to get good results. If you start with messy, jumbled data, your results will be confusing or just plain wrong. Data pre-processing is the first and most important step in any data mining project. It's all about getting your data ready for action. We clean it, fix mistakes, and make it easy to use. Without this step, even the smartest computer can't find good patterns. Think of data pre-processing as tidying up your room before inviting friends over. You wouldn't want them to trip over toys or find old snacks under the bed. In the same way, clean data helps data mining see the real patterns, not the junk. So before you get excited about fancy algorithms and cool results, remember, pre-processing is the secret recipe for success in data mining. Let's break down data pre-processing into 3 simple steps: cleaning, transforming, and reducing. First up is cleaning. Imagine a list of student grades where some are missing, some are written as A+, and some as 95. We need to fill in missing values. Maybe with the average grade, fix typos, and make sure all grades look the same. Next is transforming. Sometimes data comes in different shapes and sizes. Maybe ages are written as child, teen, and adult, but you want numbers, or prices are in dollars and euros. Transforming means changing data into a form that makes sense for your analysis. For example, turning yes and no into 1 and 0. Finally, there's reduction. Big data can be overwhelming. Imagine a survey with 100 questions when you really only care about 5. Reduction helps you keep only the important parts, making analysis faster and easier. It's like packing just what you need for a trip, not your whole closet. Each step makes your data cleaner, simpler, and more useful. Together, they help you get results you can trust. Some data is continuous, like temperature readings: 20.5 degrees Celsius, 21.1 degrees, 21.9 degrees, and so on. But sometimes it's easier to look at groups instead of every tiny detail. This is where discretization comes in. Discretization is the process of turning continuous data into categories, like cold, warm, and hot. Let's try an example. Suppose you have ages 3, 8, 15, 22, 45, 70. You can group them into child, which is 0 to 12, teen, 13 to 19, adult, 20 to 64, and senior, 65 and above. Now, instead of handling dozens of numbers, you just have 4 groups. This makes it easier to spot trends. Concept hierarchies take this idea further. They let you zoom in and out. For example, Asia is a continent, India is a country, and Delhi is a city. You can look at your data at any level, continent, country, or city, depending on what you need. Both discretization and concept hierarchies help you see the big picture in your data. They turn long lists of numbers or details into simple, easy-to-understand categories. Now let's get hands-on. Weka 3 is a free, easy-to-use tool for data mining. First, go to the Weka website. Just Google Weka 3 download. Choose the version that matches your computer, whether it's Windows, Mac, or Linux. Click the download button and wait for the file to finish. Next, open the file and just follow the instructions. Usually, you just need to click Next a few times. If you're on Windows, you'll see a file called weka3xx.x. The XX is the version number. Double-click it and follow the steps. Once installed, open Weka. You'll see a simple window with buttons like Explorer and Experimenter. Click Explorer. This is where you'll do most of your work. Don't worry, it's not scary. Weka is designed for beginners. Now you're ready to start playing with real data. Weka makes it easy to test out data cleaning, transformation, and reduction without needing to write any code. Let's try a simple experiment in Weka. First, click Open File and pick a sample dataset, like weather.nominal.rf that comes with Weka. You'll see rows and columns. These are your data points and features. Now, let's clean and transform the data. Click the Filter button. You'll see options for cleaning missing values. Try Replace Missing Values. Apply it and watch Weka fill in the blanks. Next, try Normalize to scale all numbers between 0 and 1. This really helps if some values are much bigger than others. Ready to discretize? Choose the Discretize filter. Set the number of bins or categories you want, maybe 3 or 5. Click Apply. Now, your continuous data is grouped into simple categories just like cold, warm, and hot. You can try different filters to see what happens. Each one helps you clean, transform, or reduce your data. The best way to learn is to experiment, try things out, and see what changes. In data mining, how you represent data is key. Think of a spreadsheet. Rows are data points, like students, and columns are features, like age, grade, or city. The same idea works in Weka and other tools. Good representation helps computers see the patterns. Attribute-oriented analysis helps you understand your data by focusing on important columns or attributes. First, generalization means zooming out, like grouping ages or cities into bigger categories. Attribute relevance is checking which features matter most. Maybe age predicts grades, but shoe size doesn't. Class comparison is like comparing groups. Do students from different cities score differently? Simple statistics, like averages and counts, help you describe and compare groups. Weka and other tools can do these calculations for you, making it easy to spot trends. When you learn to represent data well and use attribute-oriented analysis, you can make sense of big, messy sets of information. This is what turns raw data into real knowledge.